Okay, we're going to go through factoring methods, and then I've written following steps, but this is what I mean by following steps. Technically, each of these has steps within them, but what we're trying to do is look at this as a list of steps of how to look at the question. We're first going to look for a greatest common factor, then grouping, then difference of squares, perfect square trinomials, sum and product, and then finally decomposition. We're going to try to, every time we look at something, we're going to address number 1. And if we can't do that, then 2, then 3, then 4, until it's essentially factored. Excuse me. So, greatest common factor. When we look at this very first question, we're going to take a look at, first of all, look at the variables. Is there a variable in all 3 of the terms?
No.
No. So I can't pull a variable out of every term, so I don't think factoring out a variable is going to be a great idea. But what about the coefficients? Is there a common factor to all those? Yes, 5. So I'm going to divide all of these by 5. So when we do that, 5 goes outside, and then we set up a set of brackets. 15 divided 5 is 3, so we have 3d squared minus 3d minus 90 divided by 5.
Can't you divide 90 by 15, though?
Oh, can I? Is that a better one to use then? So then let's do that. Great job. What I was going to show you is that we would have got a value here, and then we would have ended up dividing by 3 again, and then we would have done 3 times 5 outside. We would have got 15, but because you noticed this, it's way better to get the greatest common factor first. We essentially just had a common factor. So let's take 15 out of everything. Now when we take 15 out, 15 divided 15, just a value of 1, a value of 1. And then what's 90 divided by 15? Fix this.
6?
Yeah, 6. Great. Are we done? You don't know?
No.
No. Let's go through the next one. So we've done greatest common factor, and it looks like it's checked out. We got that. Grouping. Groupings tend to be pairs of stuff. So if I very quickly look, I could factor out a D there, but it's not going to be that helpful. I can't really factor anything out of that, so it doesn't look like grouping is going to come in very handy here. So I'm going to say we checked it, and there's nothing we can do. A difference of squares is essentially 2 values. We'll call it a squared minus b squared, and that difference is that subtraction sign. If we have a scenario where we can find like square roots to 2 terms beside each other, and when we look at this, I don't have that scenario. So I'm going to say we looked at difference of squares, nothing there. A perfect square trinomial is where we have 3 terms that end up in a situation like this. Plus b squared. So you're looking for 3 terms where if you square root the first term, square root the second term, and then multiply them together and multiply by 2 would be the middle term. And it doesn't happen here. We're going to have a root 6. It's not going to happen. So I know we look for them, difference of squares and perfect square trinomials. They're pretty rare. We're going to do questions with them. But what's interesting is we can actually not quite sum it. Well, we can sometimes sum and product some of them, but we can always do decomposition to all of those. So always think of worst case scenario, look for decomposition. Anyways, our order is the next step is sum and product. A sum and product can only be done when the first term has a coefficient of a. So you might refer to it as like ax squared, something like that. This coefficient has to be 1 to do a sum and product. Okay. Luckily, we have a coefficient of 1. So this is somewhere where you can use sum and product. So sum and product works where I'm going to name these coefficients really quickly. We're going to call this one A, this coefficient B, and this constant, because there's no variable there, C. And we're going to look for 2 numbers that multiply to C, and those same 2 numbers are going to add up to the coefficient B. Okay? So
2 numbers that add up to -1 have to multiply to -6.
Very good. Yeah, so 2 numbers that multiply to -6, and those same 2 numbers are going to add up to -1.
So
think of any values.
-3 and 2.
There you go. -3 times 2 gives you -6, and -3 plus 2 gives you -1. Excellent. So what's neat about sum and product is these two values actually become the constant terms in your set of brackets. Now, you still got to bring down your greatest common factor. The variable, which in this case is d, you can just put a d in the front of each of these binomials you're making. And then it doesn't matter which, but I can take -3 and put it into one bracket, and I can put
+2.
yes, +2 in the other. And it doesn't matter the order in this specific one for sum and product. Sum and product is really neat because you can just jump to this step. In decomposition, you kind of do a step like this, but then there's like a splitting of the factoring. There's an extra step
Oh yeah, I
involved.
remember.
Yeah. Okay, so just keep in mind sum and product is for when your coefficient a value is 1. So we've done that, and we checked them all out. Let's go to the next one. So here we go. Next question here. Yeah. Greatest common factor. I'm going to look through all of these. I don't have a variable in every term. I mean, I could try to turn this into a trinomial here and then hope that 20 does something at the end, but unlikely. And if I look at all the constants and coefficients together, I can only take one out. That doesn't help us at all. So then the next thing I'm going to do is grouping. Okay, so I'm going to try to break these into 2 pairs. Okay, and I'm going to take a look. Take a look at this pair. Now, part of what's neat about grouping is once you've decided you're going to do grouping, you go back to greatest common factoring again. So in this specific group, okay?
Oh, don't you have to find like the 2 best that go together?
Yeah.
Like,
And what we can do is we can iterate and try a few, because when you do them in your head, you actually are doing the entire grouping process and then writing it down after. You can write down a couple of them and just decide, okay, this one ends up being the best. It doesn't technically have to all be in your head. So we're going to try that. So we've paired our 2 up.
so that one is x.
Great. So we have a common factor here of x. So when we take x out, we're left with x plus 5.
And that
Okay.
one's 5.
And in this one, what's the value?
5.
I can't take 5 out of 4 very nicely.
Oh, sorry.
Yeah.
I
That's okay. They look like that. What value do you think instead?
4.
Yes.
Not 5.
And I want to ask you about the 4. Do you think it's best to take positive or negative 4 out?
Negative.
Yeah.
Because they're both negative.
Very good idea. Yes. And that way we're going to left with a set of brackets that have positive numbers. And you're going to see how that plays in here. So when I take out -4, I'm left with x and positive 5. So this taking out of the negative values is extremely important because now I have 2 brackets that are the exact same value. Okay? So what I'm about to do
Oh,
is...
I remember this.
What do we
You
do?
put that and that together in one
Yes.
bracket and that and beside it.
Mm-hmm. And so what you've just said, because you didn't point to
Yeah.
anything on there, but that's okay, is you've taken out, essentially you've common factored again, okay? We're common factoring these brackets out. So you end up with x plus 5 is one set, and then in the other set, it's x minus 4. And you might just think, okay, that's just how math works. But you actually know how to do this. This visual is really hard. So what I'm going to do is I'm going to kind of show you what we did over here. I'm going to say let, have you ever seen this before? Let
Yeah.
a equal x plus 5, okay? And I'm going to rewrite this question. So we have x, a, minus 4a. Now what can I common factor out of here?
A.
I can common factor a. So a comes out, and I'm left with x minus 4. That's this bracket here, check. But what did we say a was equal to?
X plus 5.
So we plug it back in, x plus 5. And then we still have this one, x minus 4. There we go. That's how we got the 2 things there, okay? You don't have to write this every time. If you know this, just fire away, okay? Next question. Greatest common factoring to start. This is going to be important here. Do you see a greatest common factor?
Yeah.
What do you see?
2.
2. Okay. So if I take the value of 2 out, I'm ended with 2, bracket 32 divided by 2. What do you think that is?
16
Okay.
minus e to the power 4.
Minus e to the power 4. Excellent. Okay. Now this one, it's interesting. There's only 2 here. We're going to look by grouping, because that's what we always do. And this is actually just a set of 2, and grouping essentially deals with pairs. So we've already done our common factoring. Because remember, grouping, you put things as pairs, and then you go back to greatest common factoring We only have a pair here.
Can't you do difference of squares?
Ah, very good. Next thing we can do is difference of squares. And remember, difference of squares is two values that we can square root. That's essentially what they're looking for. I can find the square root of 16, and I can find the square root of e to the power 4. So, what's neat about this is essentially you're going to end up with a minus b as an answer and a plus b as an answer. So, the common factor comes down. We still have 2. And I know I'm going to have two brackets. One will have a plus sign, one will have a negative sign. The question becomes, what are our a and our b? So we're going to take this as our a value, we'll call it 16, and we're going to find the square root of it. So what is the square root of 16? 4. So that 4 goes in, and it's going to go in the first position of each because that was the first position value. That's a negative sign. I know I just kind of messed it up. There we go. And then we're going to find the square root of e to the power of 4. What do you think
squared?
That is? E squared. Ooh. And that's going to go in the second position. Now, something really interesting has happened here, okay? I'm going to write this all in black. 2, 4 plus e squared, 4 minus e squared. Now, okay, take a look. I know that this checks out. That's a 2. This bracket checks out. Take a look at this bracket. Is there anything you can do with this bracket here? Just that bracket. It's a really special thing that happened here. Take a look at this. Ooh, that's what I wanted. Take a look at this step again. Can I find a difference of squares of just that bracket?
Yes.
Well,
yeah.
I can.
Because
It's an interesting scenario. Yeah. So, we're going to just work with that bracket. We'll split it, and then we'll get our final answer.
Do it with that one?
Why can't I do it? What does the word difference mean?
Oh, subtraction.
Yeah. Does this one have subtraction? No. So we can only do it with this one. I'm going to ask you quickly and see if you can get it for us. I'm going to bring down the rest of the stuff. 2, and then 4 plus e squared. Now, again, we're going to get two sets of brackets. One's going to have a plus. One's going to have a negative. And we just got to square root our terms. So what's the square root of 4?
2 minus e.
And 2... What's the square root of the second term, sorry?
E.
E, very good. We get e and e. Can I continue with this practice here?
No.
No, not nicely at least. There we go. That was a really tricky question there. The fact that you had to do a difference of squares twice, okay? Finally, this question here. Greatest common factor. Do you see anything?
No.
No, no greatest common factor. Factor by grouping. If I split them, I'm left with one value out. It's not very helpful to us, so that's not going to help. Difference of squares. It's not two terms, so we've checked off all of those. Perfect square trinomial is where you get a squared, and you could say that there's an x here maybe. Plus 2abx plus b squared. Okay, and if you get that scenario, you end up with ax plus b squared. You learn it with two brackets that are the same. Okay.
Oh yeah. Okay.
If you take the best way to solve this is to just look at the first coefficient and the last constant. Can you square root them? Can you square root coefficient 1? Yeah.
Yes.
So let's keep that in our mind. I can get square root of 1 is 1, so that's an important value. Square root of 144, what's that?
12.
12. And if I multiply these and then multiply by the number 2, that's this 2 in here.
It'll give you that.
It'll give me that. So that means this is a perfect square trinomial. So instead of doing all my sum and product and decomposition work, I can go straight to this. Square root of the first term
is u.
You're right, is u. Okay. And then the middle term is a plus. It could be a subtraction sign too. Could it be? Yes, but the last term would be subtraction. We're going to bring down the plus. And then what's the square root of 144?
Plus 12.
Yeah, positive 12. And then we're just going to put a squared there.
Wouldn't you put the 2 on the outside of the bracket? Because don't you just multiply by 2, I thought?
This 2 is just to let you know part of a process. So the reason this happens, I'm going to do the expansion now, okay? So technically that's the factoring. It was really, really quick.
Oh, we already did that.
Yes, we already did that part. Now, we didn't do a decomposition question. sum and product and difference of squares can technically be decomposed, and then you can kind of realize after. So I'm going to decompose this one also. So let's say it's u squared plus 24u plus 144. Maybe we didn't notice it was a perfect square trinomial. In order to do decomposition, we could technically do a sum and product here, but decomposition is actually, remember I referred to these as an a coefficient, a b coefficient, and a c constant? Yes. Decomposition is actually two numbers that multiply to a times c, and the same two numbers add up to the coefficient b. So, in our case, two numbers that multiply to, well, 144 times 1 is still 144. So it's turning into a sum and product almost. And those same two numbers are going to add up to 24. Can you think of two numbers that multiply to 144?
12.
Yes, very good. 12. Let's do a different color. 12 and 12. So in decomposition, we would then say u squared and plus 12u plus 12u plus 144. What has happened here is I should probably move it down a little.
Don't you then... Oh, sorry.
Oh, that's okay. Let me see if I can realign that. There you go.
Don't you then put two together?
So if we put together, what's 12u plus 12u?
24u?
Yeah. We're just going back a step. Decomposition.
No, but don't you just put two together?
Yeah. The next step in decomposition is to go back and do some grouping.
That's what I meant.
Yeah, you're exactly right. Very, very good. And then from grouping, greatest common factor again. So within each group, what's the greatest common factor of this pairing?
U.
Yeah, so we take out a u, so we get u, and then we'd end up with bracket u plus 12. And then what about in the second pairing?
12.
12. So we take out positive 12, and we're left with u plus 12. Now, remember we did this before. It's like a common factoring again, but essentially you get u plus 12, and then u plus 12. But we have two brackets that are the same. Can I simplify that?
Yeah.
U plus 12 to the power of 2, which is the original answer we got. Now, we pretty much tackled everything. The one thing I didn't tackle that I said we could is a difference of squares using decomposition. I'm going to very, very quickly do that for you, okay?
Okay.
I'm going to make one up. X squared minus 49, okay? If you remember, so I know this is a difference of square. I know I can square root x, I can square root 49. I'm going to get 7 and x, and I'm going to get x minus 7, x plus 7. Great, I know that. But let's say I didn't notice for some reason. For decomposition, remember I said I need an a coefficient, a b coefficient, and a c constant. I have a c constant, it's negative 49, and I have an a coefficient, it's technically 1. The question is, what is b? If there's nothing there, what
Plus
number?
0.
Very good. So I can break this into x squared plus 0x minus 49. Now I have a c, a b, and an a. Okay? So here's what's interesting. Remember, we need two numbers that multiply to a times c. In our case, 1 times negative 49, well, that's just negative 49. And those same two numbers need to need to add to 0. What two numbers multiply to negative 49 and add to 0? What's neat about this is to add to 0.
Oh, multiply to 4. Negative 49 and
Remember,
0.
Well, if you add 49 and 0, you're not going to get 0. In order to add two numbers and get 0, they have to have the same value. So can we think of a number that you multiply by itself and you get 49?
Oh, negative 7 and positive 7.
Negative 7, positive 7. Those work. Okay? So I'm going to bring this over. We'll talk about decomposition again.
Can't you just make that just the plus?
Yeah, technically I'm showing integer. I just kind of filled in a template. You're right. It's technically just 1 plus value. This splits, okay? So I'm doing a difference of squares, and I'm going to say plus 7x minus 7x minus 49. Well, now, decomposition, we set up our groupings, and we look for greatest common factors. What's the greatest common factor of the first pair?
X.
So we take x out, and we're left with x plus 7. What about the second pairing?
7. I mean, negative 7.
Yeah, negative 7 is even better than 7. Negative 7, and we get x plus 7. So again, these two brackets are the same, so we can common factor that out. So we have x plus 7, and then we have x minus 7. Now, here's the thing. Look at all this work I did for decomposition, where if I recognize it's a difference of squares, I go right to the answer. So that's why, in this little list I gave, look for difference of squares and perfect square trinomials first, because if you see them, you can go right to your answer really quickly. You don't want to go through decomposition and then realize, oh, I could have done a difference of squares. But worst case scenario, if you don't notice, decomposition will still solve those questions for you. Okay?